All right, so today we're looking at domain and range. You've probably done some of this before. Just remember that your domain is talking about your x values. Range, we're talking about the y values. We're talking about everything that is represented within the problem, either from the graph or the equation or the table. However your data is represented, what are the x values that are possible and what are the y values that are possible. Sometimes you have graphs that are, and this word's not on here, but I'm going to write it down, discrete. A discrete graph has a bunch of dots. Whenever you have a discrete graph, it's possible to just list out all the x or y values that are in your graph. Sometimes you have graphs, though, that are continuous. Continuous graphs are made up of an infinite number of points. So even though you may just have a short line, it's impossible to actually list out every possible x value in between there because you have things like decimals and fractions that are all within that line. So whenever you have continuous graphs, we use different kinds of notation to describe your domain and range. One way is using interval notation or inequality. Inequality notation is the one you've actually used more before. Interval you usually see more in more advanced math classes. It's easier to write, like there's less things to have to write down, but either one you have to represent everything that's about the domain and range. So whenever you're looking at domain of a graph, you really need to look and list your points from left to right. That's going to be from smallest to biggest. So looking at your line, you're going to find the leftmost point, and that's going to start your domain, and then find the rightmost point, and that's going to end your domain. Be sure when you're doing this, you're looking at the x values. When you're looking at range, you should start at the bottom of the graph and then work your way to the top. Again, that's going to be from the lowest y value to the highest y value. Again, remember, y value. So we have a couple of examples here, and these examples are all worked out already. Looking at this graph, again, if I want to find my domain, I'm going to find the point that's furthest to the left and figure out what is my x value right there. It's a -7. Then I'm going to find my point that's furthest to the right and figure out what is my x value there. Now notice the way they wrote this down. It says -7 is less than or equal to x, which is less than 5. Remember why this one's equal to and this one's not. Closed circle, open circle. Okay? This is an inequality notation. If you would like to put it in interval notation, it's very similar, but we're going to cut some things down. To represent a equal to, the bottom, and so less than or equal to, you're going to use a bracket. And then write your -7. Then a comma in between the 5. And then a parenthesis to represent that it's less than, but not equal to. That's interval notation. We could do the same thing for our range. So looking at the range of this graph, again, I would like to start at the bottom. Well, this point is the lowest. Looking at my y value there, that's a -3. This point is the highest. Looking at my y value there, that's a 1. So again, I can represent my range using interval notation. -3 is less than or equal to, again, because this is a closed dot. Y goes in between because we're talking about the y values, and then just less than 1 because, again, open circle means it's not actually equal to. To represent the interval notation for this, we would again do a bracket for the -3, comma, and a parenthesis for the 1. Either one of these are going to be acceptable answers on your homework and assignments. What about when you have like a more continuous graph? Well, again, you're going to start for the domain. You're going to start on the left. Well, what is the leftmost point here? Well, it's right here at 0, 0. how do you know whether or not it's going to be equal to or not? Unless they specifically draw a circle point there, you're going to assume it's equal to. So my leftmost point here for my domain is going to be 0. When does this graph stop going to the right? Well, the arrow on the end indicates that it's going to continue going right forever and ever. So if we were going to write our domain here, the easiest thing to do is to just say x is greater than or equal to 0. All values greater than or equal to 0 would be in this domain. Again, that's the inequality notation. If you'd like to use interval notation, we're going to have to do a bracket again on the 0, a comma, and then when does this line stop going to the right? Again, never. So we're going to put a positive infinity, telling me that it's going to go infinitely to the right. Since you can't ever actually get to infinity because it continues on, we always use a parenthesis next to the infinity symbol. Same thing if we looked at the range of this graph. What is the lowest point? Again, lowest point, the y value is equal to 0. So again, I could use the 0 for the lowest point. But again, when does it stop going up? Even though it may look like the line is flattening out, this is actually going to continue increasing and getting taller and taller. So it does continue going up. Again, our range is y is greater than or equal to 0. Or if I'd like to use the interval notation, a bracket with a 0, comma, and another positive infinity, because it's going to keep going up till positive infinity. One last example on this worksheet. For this graph, what is the point furthest to the left? Again, I have arrows on it, so even though it looks like on this page it's going to stop right here, this graph is actually continuing up and out. Same thing here on the right side, continuing going up and out. So we say that our domain here, if it includes every number to the left and every number to the right, is going to be all real numbers. One way that we represent this is using this fancy little symbol for all real numbers. If you would like to use interval notation for this, which most people don't want to, but you could say that it is going infinitely to the left or to negative infinity, and infinitely to the right or to positive infinity. Again, parentheses on both because you can't actually get to infinity. For our range this time, do we have a lowest point? Yes, we do. It stops here at 0 and then it goes up for forever. So again, just like on the last problem, our range is going to be y is greater than or equal to 0. Or if you prefer the interval notation, a bracket on the 0 and then an infinity with a parenthesis. So this notes has some really good information and stuff on it and just kind of reintroducing you to domain and range. Let's look at some more specific examples. This first problem is already filled out for you, but we'll kind of look at it again. Domain, furthest to the left. What is the x value furthest to the left? Well, the x at that point is 1. What is the y value, or the x value furthest to the right? That's a 4. So to represent my domain here, I have two choices. I can again start with the 1. Both of these have filled in dots, so I'm going to do less than or equal to x, less than or equal to 4. Again, if you'd like to use interval notation instead, brackets on both, 1, 4, bracket. For the range on this graph, again, I'm going to find the lowest point. Well, my lowest point is right here. What is the y value there? Y is equal to 1. What is the highest point? The highest point's right here. What is y equal to there? 5. Again, I can represent this using either inequality or interval notation. Again, both of our dots are filled in, so I'm going to include the brackets. What about example number 1 down here? Again, domain, left to right. What is the value of x furthest to the left? Well, this is my point furthest to the left. Looking back up here at the line, -1, 2, 3, 4. Domain is from -4, again, filled in dot, so equal to, x has to go in between. What's the point furthest to the right? That's right here at +4. Again, equal to, fill in the circle. -4 to +4, all the possible x values. Again, if you prefer using the interval notation, brackets on both because they're both closed-in circles. For the range, again, you're going to go bottom to top. The lowest point here is right here. What is the y value there? -1, 2, 3, 4, 5. -5. Again, filled in circle, so equal to. What's the highest point? Right here. What is the y value here? It's 0. Less than or equal to 0, because again, we have a filled in circle. Again, interval notation, same two numbers, brackets on both, because it's equal to both. Remember, it's your choice on which way you use to represent your information. For domain, again, right to left, point furthest to the right, -2. Again, filled in circle, so equal to, x in between, point furthest to the right, +2. Again, we're going to put an equal to, +2. In interval notation, this looks like this. Brackets on both because both are equal to. For our range, again, think bottom to top. Lowest point, 0. Even though we don't have a filled-in circle drawn here, unless they specifically draw an open circle, we're going to assume that it's equal to. So less than or equal to y. Tallest point up here and up here, that's fine because they're both at the same point. That point is at +4. Again, those do have filled-in circles, so it's going to be equal to. Interval notation would look like this. Looking at the back of this page, again, more examples. Since we've talked about this a time or two, I'm just going to write down the answers here, and I want you to work them out for yourself. So again, left to right, domain. Interval notation would look like this. Range, bottom to top. Again, interval would look like this. Going back down the page, problem number 4. Domain, left to right. Point furthest to the left, point furthest to the right. Now, one thing about using interval notation versus inequality notation is with inequality, I put the x there, so you should be able to realize that that's the domain without having to actually label it. But in interval notation, I cannot tell whether you're identifying that as the domain and range unless you label it with something like a D or an R. So be sure you do that on your assignments. Range, again, we're thinking bottom to top, lowest to highest. In interval, it would look like this. Looking at problem number 5, domain, left to right, left to right. All of the examples on this page have had equal to places. Interval notation, range, bottom to top, bottom to top. We're going to assume that this is at 2.5, so I'm going to put 2.5. Just a few more examples. Question number 6. Domain, left to right. An interval looks like this. Range, bottom to top. Interval would look like this. 2 more. Number 7, domain, left to right. Interval looks like this. Range, bottom to top. Be sure you're giving me the y values. Interval would look like this. Last example, number 8, domain, left to right. Be sure you're giving the x values. Or an interval. Range, bottom to top. Be sure you're giving the y values here. Interval would look like this.